is section 4.6 on isosceles and equilateral triangles. And we're going to first of all look at an isosceles triangle theorem. Not to be confused with the definition of an isosceles triangle, which would say that two or more sides of the triangle are congruent to each other. In this one, we have two sides congruent to each other. And if I named it triangle ABC, I could also say the segment AC is congruent to itself. So with side, 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 I could say that ABC, the triangle going around in this order, triangle ABC, is congruent to triangle CBA. So it's not very often that you can name the triangle in two different ways and have it be congruent to itself. And what's significant about that is how the letters are matching up. Angle A is congruent to angle C. In other words, because we can name this triangle congruent in two different ways, we could say then that by corresponding parts, this angle is congruent to that angle. In other words, when you have two sides of a triangle congruent, then the angles opposite those sides would be congruent to each other. And like that previous method, if we have two angles that are congruent to each other like this, we would have enough to prove that this triangle is congruent to itself, again, in a different order, which means that if these two base angles are congruent to each other, then these two legs are going to be congruent to each other. The legs are congruent, and then here's our base, which may or may not be congruent to the other ones. So if you go from the angles to the sides, it's called our isosceles triangle converse. Next up, we have our equilateral triangle corollary. The corollary is kind of like the tag along, the little younger sibling, that because something else is true, it's going to work for this one. In other words, if we have an equilateral triangle, that means it also has to be isosceles. So if these two sides are congruent to each other, it means these two angles have to be congruent to each other. And if these two sides are congruent to each other, it means these two angles have to be congruent to each other. In other words, if all three sides are congruent, then all three angles are congruent. While this isn't a definition, the biconditional still works. If all three angles are congruent to each other, then all three sides would have to be congruent to each other. Again, that is our equilateral triangle corollary. Let's look at some examples. I'd encourage you to pause the video, try them on your own, and when you're ready, look at the answer and listen to the explanation. So in this one, we're told that VST is isosceles, its perimeter is less than 45. Which one of these sides is the base? In other words, the legs are congruent to each other. Which one is the base? The one that is not necessarily congruent to the others. As I look at this drawing, I think that these are my two legs, meaning that would be the base. So I think that 10 is equal to x plus 7. So again, I think that ST, answer the question, is the base. If that's true, then x plus 7 equals 10, which means that x equals 3. And if we look at the different sides of the triangle then, this length is 10, this length is 10. Plug 3 in for the bottom side. 2 times 3 minus 8 means that this length is -2. Uh-oh, that doesn't work. So ST actually isn't the base. Let's try another case. And what if VT is the base? A little bit of trial and error in here. If VT is the base, that means 10 is equal to 2x minus 8. 2x equals 15, x equals 9. Now to run that through there, if x equals 9, and this length is 10, plug it in down there. That should be 10 as well because they're equal. Plug it in over here. 9 plus 7 is 16. So this makes sense. If I add up all those sides together, this perimeter is only 36, which means it is less than 45. And if I wanted to check, I could see, well, what happens if SV is the base? If that's the case, then x plus 7 equals 2x minus 8. Add 8 to both sides, subtract x from both sides, x equals 15. You plug it in, 15 plus 7 makes this length 22. Plug it in down here, this length is also 22, so we have 22 plus 22 plus 10, which is bigger than 45. So that cannot be the base either. It means our question, or the answer to the question, is that VT is the base. All right, in this next example, we have an isosceles triangle. And we have a couple of sides that are congruent, which means the opposite angles are congruent. So this is going to be 2y plus 64 degrees as well. 180 degrees in a triangle. If we take 180 minus 55, that means these two angles are going to split the remaining 125 degrees. So we can add them to each other, make that equal to 125, combine my terms on the same side of the equation, subtract 128 one of our variables. If I plug it in here and I plug it in there, they're both going to be equal to 62.5 degrees. Excellent. So next, we have to go into the other triangle. And what I know here is that these two angles are going to be congruent to each other because we have another isosceles triangle. And this 62.5 forms a linear pair with this other angle. So 180 minus 62.5 is going to be 117.5 degrees. Together, all three of those angles in this non-highlighted triangle add up to 180. So if you take 180 minus that, it leaves you with 62.5 degrees to split evenly between those two angles. In other words, this exterior angle to that triangle is going to be equal to the sum of those two. So we're going to take 45 minus x over 4 and add the same thing, or in other words, just double it. That has to be equal to 62.5 degrees. Distribute the 2. 90 minus x over 2 is equal to 62.5. How about we add x over 2 to both sides, subtract 62.5 from both sides, and that's going to come out to 27.5. Then divide both sides by 2. So 27.5 divided by 2 is going to be 13.75, and there is our value for x. Next example is an argument, not a full-blown proof, but an argument. We want to make an argument that angle 3 is congruent to angle 4. Take a look at the drawing, think about some strategies that you might use, maybe pause and try to do some steps on your own. When you're ready, you can come back to the video. And what I'm noticing is that since segment RH is congruent to RE, this entire triangle is isosceles, which means the opposite angles, these base angles would have to be congruent to each other. I'll use the names OHE and SEH. And they're congruent to each other because of this new reason, the isosceles triangle theorem. Because the sides were congruent, the opposite angles were congruent. Okay, great. So we've used this. Angle 1 is congruent to angle 2. I see that angle 1 is part of this angle on the left. Angle 2 is part of the angle on the right. We're trying to get the remaining portions of those angles congruent to each other. So to tie all this together, finding a way to combine the given with what we're trying to prove, how about if we said that measure plus the measure of angle is equal to measure of OHE and measure of angle 2 plus the measure of angle 4 is equal to the measure of angle SEH. And I drew an arrow, necessarily need to do that back here because this top equation we have doesn't necessarily lead right into that one. However, if we look at what we have in this green highlighted step, and now in this yellow one, there's definitely a connection. In other words, OHE is mentioned in both of them. SEH is mentioned in both of those. So if we use double arrows this time, and notice that 1 plus 3 is equal to OHE. OHE is equal to SEH. SEH is down here equal to 2 plus 4. So we can make a big transitive. 1 plus 3 is equal to 2 plus 4. And again, that is a transitive step. Now, I haven't used them given the fact that 1 is congruent to 2. So if I look at this and subtract 1 off of the left and subtract 2 off of the right, so using that given, we would get that measure of angle 3 is equal to the measure of angle 4. And the reason for that is subtraction. We're trying to get the angles congruent, but for our sake of just making an argument, this is saying the same thing to us. There is the conclusion that 3 and 4 must be equal to each other. Next, I have another example solving for variables, trying to solve for x and y. Again, go ahead and pause it, see what you can do. What I notice is that those yellow lines are parallel. The green segment serves as a transversal. So this 4y plus 24 is alternate interior to this one. So this angle also has to be 4y plus 24. Okay. What else do we know? This is 3x minus 7. These two sides are congruent to each other. So this is going to be equal to 3x minus 7. Now we have inside of this triangle, we have these three angles adding up to 180 degrees. So if we combine like terms, 6 minus 14, adding those two, plus 4y 24 equals 180. And if we simplify that a little bit, 6x plus 4y is equal to 170. So there's an equation, two variables, two unknowns. And the other thing that I noticed right away is that these two angles form a linear pair, which means they have to be supplements to each other. So we could also add these up, 5x plus 9 and the 4y plus 24 together add up to 180. So combining like terms, 5x plus 4y plus 33 is equal to 180. But if we subtract 33 off of the left, we can subtract it off of the right. And that's going to be 147. Combining these two equations together now using some algebra skills, but we multiply this red one by a negative, black one just the way it is, 5x 4y equals 147. Add them together, the y's cancel out. We get negative x is equal to negative 23, which means x equals positive 23. One of our answers, if we plug it back in somewhere, let's go ahead and try for this one. So if x equals 23, 5 times 23 plus 4y is equal to 147. 5 times 23 would be 115. 115. 4y equals 147. Go ahead and subtract 115 from both sides. That would give us 2, divide by 4. So then y equals 8. Next problem. So given this isosceles triangle with base SO, measure of angle S is given, the measure of angle I is given, find the measure of each angle of the triangle. Okay, so when it says SO is the base, it means IS and IO are the legs, the congruent ones. And because those two legs are congruent to each other, that means the base angles are congruent. So this is going to be 5x minus 18. Now, if you add up all three angles of the triangle, they should add up to 180. So if we add them all up, 5x plus 2x is 12x. Negative 18 plus negative 18 plus 21 would be negative 15 equal to the sum of 180. Add 15 to both sides, and then divide by 12. So 195 over 12, and I believe that will simplify a little bit. We can divide those both by 3. Divide 195 divided by 12, 75. So it's 16 and 3/12. That would be 16 and 1/4, or 65 over 4. Another way to look at that. And since we're asked to find the measurement of each angle, we're not exactly done yet. We have to write this as an improper fraction, which I think will make it a little bit simpler. We have to plug it in. So if we plug it in for the top one, 2 times this x plus 21. So if we multiply this by 2, what's that? 2 times 65 over 4 plus 21, that's 65 over 2. The 21 can be 42 over 2. And if we add those together, that looks like that's going to be 107 over 2 degrees. So 107 over 2, 53.5 degrees. Measurement and the measurement are going to be equal to each other. And we can plug them in 5x minus 18. So 5 times 65 over 4 minus 18. We multiply that. 5 times 5. 325 over 4 minus 72 over 4. Subtract that. 325 minus 72, that's 253. So it's 250 over 4 degrees. Kind of a weird looking number. We could get it as a decimal, but I like these nice precise numbers. There are our 3 measurements. I'm at the last question here. Solve for each variable, and we're not given a lot of information. We're only given 2 numbers, and we're given 90 degrees here. So if we start putting these things together, start here on the inside. This is a nice Isosceles right triangle, so both of those angles have to be 45 degrees. So vertical angle there is going to be 45 degrees. These form a linear pair, so 180 minus 45 means that n is 135. Check that one off. And let's see if we can keep expanding out. Orange triangle, we've used up 70 and 45, which is 115 degrees. Take 180 minus 115, and P then would be 65. Hear that. Let's see. This triangle. Together we've used up 45 and 83. That's a total of 128 degrees. So we take 180 minus 128. That's going to be 52 degrees. S. S is 2. A little smaller triangle here. So it is an isosceles triangle. Those two angles are equal to each other. 180 minus 45 is 135. Divided evenly by those two. 135 divided by 2 is going to be measurement of t. And if I actually did divide that one, let's see, that's going to be 67.5. .5, 67.5. And we have one more, and that's going to be M, I believe. I think that's the last one we have to find. And if I look at the markings, this has 3 little markings on it. And I see that 70 degrees down here also has 3 markings. We had to really look at that one. And in this blue triangle, we have 45 and 70, which adds up to 115. Take 180 minus 115, and M is going to equal to 65.